Extracting square roots. Sometimes we're going to be faced with a quadratic that only has an x squared and doesn't have a singular x. This is where you would want to use an extraction process to help you with that. And here be our 2 steps that we're going to follow. First of all, we are going to isolate the square. After we get that squared isolated, like the x squared, we are going to square root both sides. So let's just kind of funnel through some different examples and see what we can do with that. So in this first example, it says x squared equal to 8. Step 1, isolate the square. You can see that we absolutely have this x squared by itself on the left side of the equal sign. Step 2, we're going to square root both sides. So we're going to say square root. Square and square root are inverses of each other, so that means they're going to cancel and I just get an x. Whenever you square root an unknown like this, you have the possibility of a positive or negative answer that could have been there, because through the squaring process, it would have canceled out the negative. So you do still get 2 answers. Now, what we do with that square root, we need to come over here and we need to simplify. When you're simplifying the square root of 8, you're going to break it down into its prime factors. So you want to think, what'll multiply to give you 8? You never use 1 in the number. You're going to do any other number than 1. So this would be 2 and 4. If it's prime, you circle it. Then you're going to break down the 4. And 4 is a 2 times 2. Those, again, are both primes. So what we're doing is reducing this radical. This would be the equivalent of 2 times 2 times 2 to give us 8. Because we have a pair, we can bring that out front. And so the square root of 8 is also the 2 square roots of 2. So x would be equal to plus or minus 2 square roots of 2. This is an exact reduced answer, whereas if I went to my calculator, we would be working with a rounded answer. Let's look at the next one because we're going to encounter another situation that we need to bring to the surface on how to work with. This one says factor and solve 4x squared plus 1 equal to 7. So step 1, we're going to isolate the squared. We want to get this squared term completely by itself. So I'm going to subtract 1 from both sides. That gives me 4x squared equal to 6. Divide both sides by 4. That gives me x squared equal to 3 halves. Now that I have the x squared isolated, I'm going to square root both sides. So when I square root, that gives me x equal to plus or minus the square root of 3 over 2. Now, we never leave a square root of a fraction like this because this is equivalent to plus or minus square root of 3 over square root of 2. And we don't leave a radical in the denominator. So what we're going to have to do, we're just pulling up some previous skills from previous courses. What we're going to have to do is rationalize the denominator. The way that we do that is we start with square root of 3 over square root of 2. We multiply by some big fancy 1 that changes up the problem. And what that is the square root of 2 over 2. So we're going to multiply the denominator times itself. When we do that, that gives me, because these are the same square root, we can multiply them underneath. The same is true here. So it gives me the square root of 6 over the square root of 2 times 2 is 4. Square root of 4 is positive 2. So we've now rationalized that denominator to give us plus or minus the square root of 6 over positive 2. This is the correct format for working this all the way down. Again, we're just going back to some pre-algebra skills of rationalizing the denominator. We'll post some additional helps with that or reach out if you need some more assistance. Again, we're trying to reduce down to lowest terms, exact answers. Let's work this next one. 2 more examples. Factor and solve. So first thing we need to do is isolate the square. In this case, our squared is a grouping. So I'm going to divide both sides by 3. And this gives me x minus 4 squared equal to 5. And I have my square isolated. So now I can execute that square root. I square root both sides. That gives me x minus 4 equal to plus or minus, don't forget that, square root of 5. Now I'm not going to mess with any square roots until I'm done getting x by itself. So now I need to add 4 to both sides. This gives me x equal to positive 4 plus or minus the square root of 5. 5 is prime, so I'm not going to do anything else with it. There's nothing I can do with it. You can keep it as positive and negative square root of 5 plus 4. We just typically put that 4 in the front so it doesn't accidentally get under that radical sign. So this one's not too bad. We didn't have to simplify it. We didn't have to rationalize it out. Let's look at the application of this. Find the length of the missing side. If you remember from your math knowledge, the Pythagorean, spell it right here, Pythagorean theorem states that in a right triangle, a squared plus b squared is equal to c squared. So if in this triangle, I'm trying to find the side that's missing, let's call this A, B is always your other side, and then C is your hypotenuse. That means I would be looking at a squared plus b squared equal to c squared. Let's plug in our b's and c's. So a squared plus 4 squared is equal to 12 squared. Solving this out gives me a squared plus 16 equal to 144. And now we're to what we're doing when we were solving for x. I just have an a there. So I'm going to subtract 16. So I get a squared equal to 128. Now that I have it isolated, I can square root. So I get plus or minus the square root of 128. Because this is an application sense, we actually only want the positive because I can't have a negative side length on a triangle. And then one last time, let's work with 128. We're going to break it apart. So you think, what will multiply to give you 128? With these even numbers, I always like to start with 2 in the number. So it'd be 2 and 64. Break it apart again. 2 and 32. Break it apart again. This could be 4 and 8. You could have done 2 and 16. We're still going to get there either way. 4 breaks down into 2 and 2, and I just circle every time I get to a prime. 2 and 4, and then 2 and 2. So the square root of 128 breaks down into 1, 2, 3, 4, 5, 6, 7 twos. So I'm just going to write that out. And then you look at pairs. So like this 2 could come out, this grouping could come out, this grouping could come out. So I'm left with 2 2's outside and a 2 on the inside, and you multiply these together. So it gives me 8 square root of 2. So A is equal to an exact answer of 8 square root of 2. Just want to pull this one in to show you the application of solving for an x squared, or in this case, an a squared. Again, go and attempt the problems and reach out if you need additional resources or help.